Hello everybody, this is Zero Day, and this is the IAM privesc by attachment scenario in the Cloudgoat series. We start off as a user who's actually not that low privileged. He has the IAM pass role permission, that notorious permission that we used also in the Lambda privesc video, as well as many IAM and EC2 permissions. Among those IAM permissions are adding a role to an instance profile, removing a role from an instance profile, and with the EC2 permission, we can run an instance, so we can create an instance and perform all kinds of different commands. In this scenario, we are able to remove a low privileged role from an instance profile and add a high privileged role to that instance profile. Using that modified instance profile, we can create a new EC2 instance, and after SSHing into that EC2 instance, we can query the metadata service to obtain the credentials for that role and completely compromise the AWS account. We were provided the access key and secret key of a user, so let's just configure that into our AWS CLI. But before doing that, I'm running a tool called AWS CLion, so let's configure that first with AWS CLion -- engagement, and we'll call it IAM privesc by attachment. This tool is made to keep your pen tests, your AWS pen tests, efficient, stealthy, and organized. I'll show this tool off as we go further into the video. So let's configure this profile. We'll call it Kerrigan and put in the access key and the secret key. And that's it. And one of the really cool things about this tool is you can change your user agent. So before running any API calls, let's make sure we change our user agent because we're running within a parrot terminal. So I installed this tool in opt AWS CLion, and here we get some sample user agents. I'm going to choose, let's choose this Windows Boto Core user agent. So any API call that we see in CloudTrail will actually be this Windows user agent. So we could do that with AWS CLion -set user agent and just put in our user agent as well as our engagement, which is IAM privesc by attachment. So now we have this user agent. We can see any user agent that we configured in this directory. So if we go to .aws CLion, this is all of our engagements. We have a default engagement, the one that we just created, and all of our API calls will be saved within this engagement. So we'll see that as we go further into the video. You could also see all the different engagements with this command. So now that we configured this profile of Kerrigan, we should start running some API calls. So one of the first API calls that I run when I don't know anything about a user is to see if they can run some IAM service API calls. So for example, IAM list -attach -user -policies, and then provide the username. Now we can assume that the username is Kerrigan and just reduce the amount of API calls that we are doing, that we are performing. But just to make sure, we could also do this get -caller -identity command. So we provide this with Kerrigan, and as expected, this is our username. So we could put in Kerrigan here, profile of Kerrigan. And we are not allowed to. We get an access denied error. And so this is very bad when you're running a penetration test and the client wants you to be stealthy and you run an access denied call. All access denied calls are quite noisy. So you want to make sure that you avoid the access denied calls. So another thing that we can try doing is seeing if we can assume any roles. So we can list roles and provide our Kerrigan profiles. and we see that these are the roles. There's a ton of roles here. I think there's 9 in total in my AWS account. But the interesting ones are the CG Meek role and the Mighty role. We can assume that the Mighty role has more permissions than the Meek role, just because of its name. It's Mighty versus Meek. We see that the EC2 service can assume this role for both roles, and because of that, we should look at to see if we can run any EC2 commands, because if we can create an EC2 instance and use this role with that instance, then we can escalate our privileges. This is kind of similar to a previous video that I did with Lambda privesc. I'll put that video in the link, a link to that video in the description below. Basically, what we did with that scenario is we created a Lambda function and we passed a role to that function. We're going to be doing something quite similar here. So if we do AWS EC2 describe-instances, profile Kerrigan, let's just see if we can even run any API, EC2 API calls. So let's provide our region. And we see that we have one instance here with this public IP address and this private IP address. Let's see the security groups. So there's an SSH security group and an HTTP security group. So I assume that we can SSH into this machine and maybe as an HTTP server as well that we could potentially exploit. So let's do curl HTTP, and it just hangs. There's likely some security group there that's stopping our API call. We can check that out later in the video, but we can't curl the HTTP server. Let's see if we can SSH, and we can. It is open. So we can do that EC2 call. Maybe we can also create an EC2 instance. And so we could do that. If you're unsure about the command, you could do AWS EC2 help. And you can look at all the different API calls you can do in the EC2 service. The one that we're interested in is the run-instances API call. This API call will allow you to create an EC2 instance. And so let's do AWS EC2 run-instances help. And these are all the different parameters that we can specify with this API call. So let's do AWS EC2 describe-instances again so that we can get the image ID. I'm just going to use the same image ID as the other EC2 instance there. So profile Kerrigan, and again US-East-1. Now a really cool thing about this AWS CLI tool is that it detects that I already ran this command before, and instead of passing this API call to the AWS account that you're targeting, it reads it from memory. So this API call that I just ran did not get duplicated in CloudTrail. It just reduces your API call footprint in the account that you're targeting. It's also really fast because I read it from memory and I didn't have to wait for the API call to be performed. So this is the image ID and the instance ID. So let's just take this image ID here. So AWS EC2 run-instances-image-ID. Let's put this in. --instance-type. Now this is not that important to specify. It doesn't really matter what instance type you use. I'm going to use a micro instance type, and that's just so that it reduces the cost to my AWS account. I believe the default is m1.small. So then we could provide a key name. And before providing a key name, we need to actually create a key. So let's look at how to do that. So we have AWS EC2 help, put in key, and we see that there's an API call there called create-key pair. So let's create a key pair, AWS EC2 create-key pair, and then provide a key name. So this key name could be really anything. I'm going to just choose test, and we could put the output as text and provide our profile of Kerrigan and the region of US-East-1. So here's our private key. We can just copy this and do test.pem, set paste, put all of this in, and we're good. WQ, and now we have this key pair in the EC2 service. So now when we provide a key name, we could do test. And what else do we need? We have security group IDs. Let's specify those because we want to be able to SSH into this instance. So let's use the same security group as this instance here. So if we go down, we have the SSH security group. This is all, we don't need the HTTP security group. And let's see what else. IAM instance dash profile right here. This is the very important parameter that we're going to need to exploit this vulnerability, this misconfiguration. With this is basically how we're going to do this role pass. So we need to specify an instance profile, but we don't know yet what the instance profile name is. So if we go here, we need to run another EC2 API call to list the instance profile. Actually, this is an IAM list-instance-profile -profile Kerrigan. And so now we can list all the different instance profiles. We see that there is only one at the moment called Meek Instance Profile, and it's given the Meek role. So if we were to attach this profile, instance profile, to our EC2 instance, we won't get as many permissions as we would if we attach the Mighty instance profile. We don't need to change this instance profile name or anything about it. The really important part here is this role right here. So what we need to do is just remove this role. So if you could do that with AWS IAM, remove -role from instance profile, and we provide the instance profile name. So let's copy this, put it in, and we can provide the role name, which is this. And so this is what we're going to need to remove so that we can then put in our own profile. I could show you what it looks like if we don't do that. So let's just add our own role to this instance profile without removing first the previous role. So let's put in our role, instance profile name, and we put this in. And then provide our role name of the Mighty role. So let's go back here. Let's go to AWS CLI, IAM, and Kerrigan is our profile. And let's look at all the IAM commands that we ran. So we have this list-roles.txt. So let's do list-roles. And this is the output of that command. So here's the Meek role, and here is the Mighty role. So let's copy this and put it here to remove that role, to add that role, and provide our Kerrigan profile. And we get an error saying limit exceeded when calling the add role to instance profile operation. Cannot exceed quota for instance session per instance profile 1. So we cannot have more than one role for a given instance profile. And so that's why we need to first remove this role, the Meek role, and then put in our own role. So we get a validation error. This role and instance profile failed to satisfy constraint. So they want an ARN, and I gave just the role name. So let's put this whole part. I'll just copy this here. Now, we still get a validation error. --role -name. The specified value for role name is invalid. Did I copy that wrong? Let's erase it. Oh, it says already executed command. So I added this --force here at the end. This is just another CLion parameter to make sure that you can run the same API call multiple times. So it says that this instance profile name failed to satisfy constraint. Oh, I put a tilde there by accident. Now we can delete that profile. Just a little typo there. So now let's add that role name, that mighty role. And again, we need to put --force at the end to allow the CLion tool to run it twice. So now when we look again at the instance profile, --force, we can see that we have the mighty role attached to this instance profile. So now let's copy this instance profile and put it here. And although the instance profile says meek, the high privileged role is attached to it. So with this command, now let's see if there's any other parameters that we should specify. One other parameter that we should specify is to provide a public IP address so that we can then connect to this instance via SSH. So let's associate a public IP address to it. And that looks to be about it. So let's run this command and provide a profile of Kerrigan. So it said expected an equal sign, received end of file for this input. Now I put a instance profile name. So let's do name equals this, and now we should specify a region, US-East-1. And an error occurred. Security group and subnet belong to different networks. So let's also put the same subnet as the other instance. So if you look here, subnet, this is the subnet that we're going to want to use. --subnet-id, and put that in. And finally, we were able to create our EC2 instance. By the way, notice how in the metadata options, HTTP tokens is set to optional. Now, typically when you run an HTTP server for an EC2 instance, you want to set this to required. And the reason you want to set that to required is because if you look at the previous video of Cloud Breach S3, we were able to exploit an EC2 instance because HTTP tokens was set to optional. So right now, this EC2 instance is setting up, and we just need to wait. Let's describe the instances in this account and see if it is up yet. So Kerrigan, and provide our region of US-East-1. And because this is running from memory, it will not see our new instance. So let's do --force. And here is our previous instance, and this here up here is our new instance. So this is the public IP address. Let's SSH to it to see if that works. So it does. So let's do test.pem ubuntu at this server. Now, the reason we're doing Ubuntu is because this is an Ubuntu image ID, but this is something that's very common within EC2 instances. If Ubuntu does not work, then you should do EC2-user and see if that works. So let's SSH into this, and we are now into this instance. So if we want to provide any AWS command, we will see that it's not installed yet, but we could install it with snap install AWS CLI, and we have to do sudo, and also provide classic here. So here we can install the AWS CLI, so we can configure the credentials of this role into this instance. Right now I can't run any AWS commands because I don't have any credentials in my AWS credentials file. So let's get the AWS role credentials via the metadata. So we do this, latest, metadata, and as we can see here, we have this IAM endpoint because we have an instance profile role attached to this instance. So we do IAM security-credentials, and we can see the role that's attached to this instance. This is the IAM instance profile. So now we can configure all these credentials. Now we could either configure them right here in our home IP address, or we can configure that within the EC2 instance. Now configuring it within the EC2 instance is recommended because otherwise you will be triggering guard duty with an IAM instance credential exfiltration outside AWS finding. I go into depth about that in the previous video. So let's configure this, and we can call it default. This could be just our default profile. We can put in our access key, our secret access key, and also the token. So if we go to AWS credentials, AWS session token equals this. So now we can run all sorts of commands, AWS call identity, and we have an invalid, oh, I suppose I put those credentials wrong. So let's go back here, credentials, AWS, I misspelled session here, session, and let's run that again. So now we have the API call that successfully ran. And now let's look at all the permissions of this role. So AWS IAM list-attached role policies, and we have to provide our role name. So let's put that in. And we have this role that's attached, or this policy that's attached to this role. So let's do AWS IAM get-policy-version, version ID, v1, or we don't need to provide a profile since it's our default profile. And we need to provide a policy ARN. And we can see that we can perform any action on any resource. So we have completely compromised this AWS account by attaching a high privileged instance profile to this EC2 instance role. So if we go back and look at the roles, we can see why we were able to escalate our privileges. So AWS IAM list-roles, we provide a profile of Kerrigan again, and let's less this output. So first of all, we allowed any EC2 instance to assume these roles. There were no conditions applied at all. And for a role that is this highly privileged, there should be some conditions applied to not allow any EC2 instance to assume this role. Furthermore, the IAM user that we were provided had quite high privileges. If we go back to this SSH instance and we look at our user, so AWS IAM list-attached user policies, provide our profile, actually we're default, I'm not used to that, username of Kerrigan, and we see that here's the Kerrigan policy, so let's just get this policy version, version ID, and provide the policy ARN. We can see all the different permissions that was allowed for this user. We can list roles, pass a role, associate IAM instance profile. We were given all of these permissions. And so it would seem that perhaps this is not that high privileged of a user, but this user can easily escalate privileges, as we just demonstrated. So it is important to follow the principle of least privilege and make sure that you're not providing your IAM users with too many permissions.